advantage. Today, we'll be learning a technique called auxiliary fractions. There are many instances where you have to convert fractions into decimals. Sometimes you may have easy denominators to divide with, like 2, 3, 8, 5, etc. etc. But what will you do when you have denominators like 29 or 63 or 51? These are very large numbers and you cannot memorize the tables of all of them. This is where auxiliary fractions come into play. Let me teach you this technique so that it'll make it easier for you to convert these kind of fractions into decimals. Note that this technique is used only when the denominator has a number ending with 9. Okay, let's get started. Let me take an example, 5 by 19. Okay, now let me compare between the regular division method, okay, and the auxiliary fraction method. First, let's start with regular division. Do you have 0? Of course, 5 can't go by 19. So 50 by 19 goes twice. Then you have 12 as remainder, so 120, 126. So 140, right? Yeah, 140 minus 146, so 60. It's going to go twice. 57. So that means it goes as remainder is 30. So 30 will go once. Then you have 11. So it goes 110, goes 5 times. And so on. And I'm able to do it this fast only because I'm familiar with the 19th table. Okay, imagine if I got some number like 29, 39, I'd end up using the calculator if I didn't know this auxiliary fraction technique. So let me teach you how this technique works. Okay, first make sure that your number is a proper fraction. In this case, our number is a proper fraction, but if it's not a proper fraction, convert it into a mixed format and keep the whole number part separately and perform the auxiliary fraction technique only on the fractional part of that. This needs to be a proper fraction for the technique to work properly. We have our fraction 5 by 19. Just add 1 to the denominator to make it figure 5 by 20. Okay, stay with me. This might not make sense, but just you'll get your final answer as you're supposed to get. Okay, you have 5 by 20. Now this number is called the auxiliary fraction. Using this, you will find your final answer or in decimal form. Okay, simplify 5 by 20, make it 0.5 by 2. Okay, now you start dividing. This is an important step, so pay attention closely, but it's simple, don't worry. Okay, now 0.5 you divide by 2. 0 is not going to, right? Now 5 by 2, it goes twice. And what do you think the remainder is? Remainder is 1, right? Next, what you do, you take this number that we found here. You write that in remainder below to the bottom left of your quotient, right below there. And now you divide next with the entire number you got here. So we have 12. So 12 by 2. 12 by 2 gives 6. Right? So 6 and then there's no remainder. Okay? So then 0, 6 divided by 3. Okay? So 0, 6 you divide by 2, sorry, you get 3. Again, there is no remainder here. Okay? Next you can divide by 1. Okay, your remainder you get is 1. Next you divide, then 11, right? So 11 by 2 will give 5 with remainder as 1. And just like that, we have the answer, the same answer. Okay, both are of course correct, but this was way faster than the previous one. And that was the auxiliary fraction technique. This technique was fairly simple and I hope you understood it well. Okay, so let me teach you how to apply this same technique when you're having numbers that are not ending with 9 in the denominator. Okay, let me take an example. Let's take a smaller number only. imagine you have to divide by 23. Okay, so let's say 15 by 23 is your number. Okay, here it does not end with a 9. That should not be an issue here. Okay, let me tell you why. Just multiply the number you have here, multiply it by 3. So multiply both numerator and denominator by 3. Okay, then you get 45 divided by 69. Now here this number ends with 3. So this you can easily use to find the decimal part using auxiliary fractions. Now the fraction is 45 by 69. Okay, convert to auxiliary fraction, it will be 4.5 by 7 because you add 1 to the denominator and then you divide by 10 because it's 70, right? So you have 4.5 by 7 and then you follow the same process that I just taught you. Okay, 4 does not go in 7, so it's 0.45, so 6 times 42, right? So 3 is the remainder. Now 36, meaning you can go 5 with 1 as remainder for 35. So now 15, same, you can go twice with remainder of 1. And then you can go once with remainder of 5. Now you have 51, you can go 7 times with a remainder of 2. Okay, and you can go again 3 times with the remainder of 6. And so the final answer for 15 by 23, if you want to check, you can check your calculators. It is 0.652173, etc., etc. You can keep going on for as many digits as you want, but this is the final accurate answer. This is if the number is ending with 3. Let's say your number is ending with 1. Okay, 11 by 21. Multiply both numerator and denominator by 9. You get your auxiliary fraction. Okay, if it is ending with 3 as I just taught you, multiply both by 3, you get the denominator ending with 9. If you have 7, let's say, okay, multiply both numerator and denominator by 7, you get directly your digit ending with 9. So for in this example, 17 times 7 is 9. Carry and 119 divided by 9 and 189. Yeah, okay, that's how simple this technique is. Okay, so it can be used for most odd numbers when you have odd numbers in your denominator. Of course, if you have denominator a number 5, you can divide by 5 pretty easily, so that you don't need to include that in this technique. Okay, so basically this can be used for numbers with denominators ending with 1, 3, 7 and of course 9, which is the main technique. I hope you understood this very simple technique and I hope you'll be able to use it also whenever you require. Thank you and have a great day ahead.